how to work out the proton spectrum a compound would give. So let's use the example compound of ethyl ethanoate. So it's the ethyl ester of ethanoic acid. And remember that a proton spectrum only shows protons. So the only protons that we're going to see are the yellow ones here, the green ones here, and the blue ones here. This carbon and this oxygen don't give a peak in a proton NMR spectrum because they don't contain and they're not hydrogen atoms. So in the exam, you'll get a table like this and it'll tell you the chemical shift of the different types of protons that you will come across in a molecule. For example, the protons in a CH3 group of an alkane will come at between 0.7 and 1.6 ppm. The chemical shifts of a proton on a benzene ring, something aromatic, will come between 6.5 and 8.0 ppm. And we can use this information to estimate where the chemical shift of each of these types of protons are going to come. So this yellow ones here are next to a C double bond O, this one, and this looks like this sort of thing. So we can guesstimate the chemical shift of these is going to be about 2.3 ppm. And we do that by guessing somewhere near the middle-ish. These protons here, the green ones, the CH2s, are next to an oxygen. So a CH2 next to an oxygen comes between 3.3 and 4.3 ppm. So again, because we don't know, we're going to guesstimate, we'll say they come at about 4.0 ppm. And finally, the blue ones here are alkane type protons. So those come at between 0.7 and 1.6 ppm. So if we plump for about the middle, we can guesstimate they come at about, say, 1.0 ppm. All these numbers here are estimates, and they're based on the type of protons that these are. This one could come anywhere between 0.7 and 1.6. This one could come anywhere between 3.3 and 4.3. And these here, the ones next to the carbonyl, could come anywhere between 2.0 and 2.9 ppm. So when you're working out what an NMR will look like, it's often helpful to draw out a table like this. So the protons, the chemical shift, the integration, what that certain thing is next to, and what it will be split into. So the next column we're going to look at is the integration. So the yellow ones have got 1, 2, 3 protons, which means the integration here will be 3. Of the green protons, there are 1, 2, so the integration will be 2. And then finally, for the blue protons, there's 1, 2, 3, so the integration for that will be 3. The next column we're going to fill in is the next to column. So this thing here, the 1, 2, 3, 3 yellow protons, is next to a C double bond O. This one here. The green are next to 2 different types. It's next to, on the right hand side, a CH3, and on the left hand side, next to an oxygen. And finally, the blue protons here are next to the green CH2s, which we've put in here. So now we've filled in all of these bits of the table. The next thing we need to is work out the multiplicity of the splitting. So how can we calculate the splitting pattern to work out the multiplicity or the splitting of a signal? So we have to use the n+1 rule. So what we do is look at how many equivalent hydrogens there are on the adjacent carbon or carbons and add 1 to this number. This is the number of lines that this hydrogen is split into. So to work out how many lines this carbon here is going to split into, it's next to a C double bond O. A C double bond O has 0 hydrogens. So the n+1 rule says we add 1 to that number. 0 plus 1 is 1, which means that these protons here will be split into one line. It'll be a singlet. Looking at these two here, they're next to an oxygen and they're next to a CH3. So there are 1, 2, 3 hydrogens here. So we add 1 to that, which is 4. So these two here will be split into 4 lines, which is a quartet. So finally, looking at the number of lines that these protons are split into, these protons are next to a CH2, 1, 2, this CH2. We add 1 to the number of protons there are on this bit. So 1, 2, 2 plus 1 is 3, which means that these signals here will be split into 3 lines, and we call that a triplet. So now we have all the information that we need. We have the chemical shift, we have the integration, and we have the multiplicity, the splitting, the number of lines that each signal will be split into. And from that, we can draw what we think the NMR might look like. So the yellow protons have got a chemical shift of 2.3, and they're going to be a singlet. The green protons have got a chemical shift we think of about 4, and it's going to be a quartet. 2, 3, 4. And the blue protons have got a chemical shift of 1, and it's going to be a triplet. 1, 2, 3. And that's a good prediction of what we think the proton NMR of ethyl ethanoate might look like.